The parabola shown in the graph is defined implicitly by the equation of this equation. Find the coordinates of point A where the tangent line is vertical. So in letter A, let's take the derivative. So A, we have 2x, and then first times the derivative of the second, plus the second times the derivative of the first, but the derivative of the first is negative 2. Then we have plus 2y dy dx minus 4 is equal to 0. Let's factor out a dy dx, and we get 2y minus 2x, and everything else to the other side. We have 4 plus 2y, and then minus 2x. dy dx is equal to 4 plus 2y minus 2x over 2y minus 2x. Now we can divide everything by 2. So we get 2 plus y minus x over y minus x. Now we want to know where the tangent line is vertical. So we're going to set the denominator equal to 0. So that means y is equal to x. And that'll make the denominator 0. So let's go back to the original and let's plug x's in for all of the y's. So we get x squared minus 2x squared plus x squared minus 4x is equal to 8. So x squared minus 2x squared is negative 1 plus 1 is 0. So we end up with negative 4x is equal to 8. So x is equal to negative 2. So the point's over here, and so the x is, that's negative 2. Let's plug negative 2 back in for the x's in the original. And we get 4 plus 4y plus y squared plus 8 equals 8. We have y squared plus 4y plus 4 is equal to 0. Now that factors into y plus 2, so we have y plus 2 squared is equal to 0. So the y is equal to negative 2 as well. So we have negative 2, negative 2. So this point is negative 2, negative 2. For letter B, find the coordinates of point B where the tangent line is horizontal. Well, now we want to set the top of the derivative equal to 0. So 2 plus y minus x is equal to 0. Let's solve for y. Y is equal to x minus 2. Now we're going to put x minus 2 in for the y's. So x squared minus 2x times x minus 2 plus x minus 2 squared minus 4x is equal to 8. So we have x squared minus 2x squared plus 4x plus x squared minus 4x plus 4 minus 4x is equal to 8. Well, the x squared, let's see, x squared minus 2x squared is negative 1 plus x squared. The x squareds are gone. 4x minus 4x, that's gone. So what we're left with is 4 minus 4x is equal to 8. So negative 4x is equal to 4. X is equal to negative 1. So this point, the x is negative 1. And let's plug negative 1 in for the x's in the original. And we get 1 plus 2y plus y squared plus 4 is equal to 8. 4 plus 1 is 5. If we minus 8, we have y squared plus 2y minus 3 is equal to 0. We have y plus 3 times y minus 1 is equal to 0. So y is negative 3 for the point that we're looking at. So this is the point negative 1, negative 3. And this one, you know, about right here, let's say, that's the one where y is 1. but we're looking for the point -1, -3. Find y prime. Y prime is equal to 2 secant of the third root of x. So we multiply by 2, reduce the power by 1. On the inside, that's x to the 1/3. So the derivative of this is 1/3 x to the -2/3. So we're going to multiply by 1/3 x to the -2/3. We can clean this up a little bit. 2 secant of the third root of x over 3 times the third root of x squared. Y prime here is, that third is just to the x. So we have 1 over x to the third times 3x squared. And 2 of the x's are going to cancel, so we're left with 3 over x. Y prime here is equal to -1 over. We have the square root of 1 minus 4x squared, and then times 2. Y prime here is equal to 2 sine of x squared plus x, but then times the derivative of the inside, which is 2x plus 1. The first derivative for this one is e to x to the third times 3x squared. I guess that's it. So it's 3x squared, e to the x to the third. And then the second derivative is first times the derivative of the second plus the second times the derivative of the first. Well, that's 9x to the fourth e to the x to the third plus 6x e to the x to the third. We're going to factor out a 3x e to the x to the third. So we get x to 3x to the third plus 2. Third derivative here. First derivative is 3 times 2x minus 4 squared, but then times the derivative of the inside, which is 2. The second derivative is, well, this is equal to 6 times 2x minus 4 squared. Second derivative is 12 times 2x minus 4 to the first times 2, which is 24 times 2x minus 4. Now we could distribute this. 48x minus 96. And so the third derivative is just going to be 48. Another way to look at it is you have this 24 and then this to the first power. So 1 times 24 is 24. Reduce this power by 1, that'll be 0. And then multiply times the derivative of the inside, which would be 2. That'll still get you 48. Here we want to find the second derivative. The first derivative, I probably shouldn't write it like that. First derivative is 2x plus 2y dy dx is equal to 0. So the first derivative is if we subtract 2x, divide by 2y, we get negative x over y. So the second derivative is equal to bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. But we know what dy dx is. We have negative y plus x times negative x over y squared. Well, we need to get rid of this complex fraction, so we're going to multiply everything by y. So that's equal to negative y squared minus x squared over y to the third. But we can factor out a negative 1 on top when we get y squared plus x squared. over y to the third. But we know what x squared plus y squared is. It's 20. So the final answer is negative 20 over y to the third. Where are the slopes of the tangent lines vertical and where are they horizontal? Well, this is the same as 3x squared over e to the x. So y prime is bottom times the derivative of the top minus the top times the derivative of the bottom, and then over the bottom squared, so e to the 2x. We can factor out, let's see, a 3x e to the x. That's going to be 2 minus x over e to the 2x. So where are the slopes of the lines vertical? So vertical is nowhere. We cannot make e to the 2x 0. So none. Horizontal, on top, we have 0 and 2. So x equals 0, x equals 2.